Calculus. If you missed class today, this is what we covered. We actually did all of the notes for lesson 2.2, at least for part A. We will finish lesson 2.2 after we do part of lesson 2.3. So for now, we've done all that we need to do in lesson 2.2, and we did those notes today. So today you're learning basic differentiation rules. They're going to be covered in this lesson, and to get your class started, I showed them a table that kind of looked like this. And what I had your class do was basically I gave them the problem on the left, and I gave them the derivative on the right. And they had to connect the dots and figure out what the rules were with starting with the original function. Say if I start with f of x here and I end up with a derivative of 2x, how am I getting from here to here? So they came up with some rules and some ideas by looking at all the examples that I gave them. So today's goal is to get you to use some rules and procedures rather than a limit to find your derivative. So the work's going to get much shorter and simpler. And so your class compared, they went from here to here and here to here, and they made generalizations. This one right here threw them for a loop, so they had to stop and think about that for a minute. And same thing with this one here. That was a little tricky. So in general, here's what's happening. The kids notice that when I go from x squared to 2x, all I'm doing is taking the 2 on the original x squared, bringing it down to the front, so that would make it 2x, and then lowering my exponent by 1, so that makes it 2x to the first. So they picked up on that pretty quickly. The exponent comes down to the front, becomes a coefficient, and then the exponent drops by 1. If you remember in Unit 1 Plus, we started with quadratics, and then when we found the derivative, that went to a linear x to the first equation. So they knew already that we lose a degree when we find a derivative. Then they were concerned with the derivative here of 9. And they said, well, you don't have anything over here. And I said, well, think about this as the line y equals 9. And what's the slope of that line? Well, it's 0. If I'm finding a derivative, I'm finding slope. So this is actually 2x plus 0 because the slope of 9 is 0. Or the slope of y equals 9 would be 0. So for this piece, if I look at that as just y equals 3x, the slope of that line is 3. And for the negative x squared, bring your 2 down in front, drop your exponent by 1. And so they went through the motions, and that seemed to work pretty good on this one. Bring the 2 down, drop it by 1. This is 1x. The slope of the line of 1x is just 1. And if this were y equals negative 3, the slope would be 0. And this one was pretty straightforward. Brought down the 3, and then you have x squared. This one stumped them for a bit, so you have to rewrite it this way. And so I'm going to come over here now and show you all of the steps it would take. So first, I'm going to rewrite it. Anytime you have a square root with derivatives, you have to rewrite it with an exponent. Now I'm going to start taking the derivative, so notice that my notation changed. I put the prime on there. I bring my 1/2 to the front. I drop 1/2 by 1, so 1/2 minus 1 is negative 1/2. I want to leave my answer with a positive exponent. And here I am. And then this one also has a rewrite step. The x in the denominator has to be brought to the top. And so if I'm finding its derivative, the derivative of 1x is just 1. Think of this again as the line y equals x. The slope of that line is 1. And then 4 times -1 is -4. Lower my exponent by 1, but would make it -2. And then I'm right here. All of these rules that I've used are up here in your notes. So the kids actually came up with these rules on their own. So this just says the derivative of a constant is 0. So for example, if f of x is 3, f prime of x would be 0. The power rule just gives me permission to bring my exponent down to the front and lower it by 1. So if f of x is, say, x squared, then f prime of x is 2x. Another application would be if f of x is 3x, f prime of x would be 3. And to tie that into the power rule, I could write that as 3x to the first. Bring my exponent down, multiply it by 3. I would have 3 x to the 0 once I drop it down 1 degree, and x to the 0 is 1. So I just still get 3. So when it's linear, your derivative is going to be the number in front. That is the slope. This is a constant multiple rule. So basically it just means if I had 8x to the 10th, then, if I had f of x equals 8x to the 10th, then f prime of x would be 8 times 10 x to the 9th, which would make it 80 x to the 9th. And this last rule just gives me the permission to take the derivative of pieces, so of individual terms. If f of x is 5x to the 4th minus 2x squared plus 6, f prime of x would be, bring that down, 20x to the 3rd minus 4x plus 0. So it allows me to take the derivative of individual pieces. All right, these are the examples we did in class. There's a few. Oh, I should back up. Right here, you have theorem 2.6. So these two derivatives for your trig functions have to be memorized. So you have to know that when f of x equals sine x, f prime of x is cosine x. And you need to memorize when f of x is cosine x, f inverse, not f inverse, sorry, we're doing inverses in pre-calc. F prime of x is negative sine x. Okay. These again are the examples we did in class. And so on this first example here, I had them take the 4/5 and just write it as a coefficient. And then they multiplied it by 2 and dropped it, the exponent down by 1. The derivative of -6 was 0. So our final derivative is here in purple. On number 2, they rewrote it. This right here has to be brought up with a rational exponent and brought to the top. And so once you drop your exponent and multiply and reduce it by 1 and take the derivative of 5x, you'll have this. And then you'll have this answer that I circled in blue. And so the general rule of thumb is you want to leave your answer with positive exponents. And ideally, you would like to leave them in the form they started with. So you actually started with radicals right here. And so typically you'll end with radicals. So there's your radical, and there it is reduced. All right, on this next one, you can have one more rewrite step here if you'd like. That just brings the -3/2 out to the front. So its derivative is -3/2, and then bring the 2 down to the 6 and drop your exponent by 1. On number 4, you have a rewrite step. 2x to the third is 8x to the third. And then bring your x to the top, then find your derivative. The trig functions are actually quite easy to do. You just have to have them memorized. We ended class today with proof on why the derivative of sine x is cosine x. And so I started with sine x right here. I used the limit definition of a derivative from 2, 1. And then, let's see here. This right here, if I apply my formula right here from chapter 5 in pre-calculus, when we did our identities, I will get these two terms right here. So if I expand this one with my formula here, I will get the first two terms there. The two yellow highlighted terms, I factored out a sine from, and so that's going to be my next line of work. I factored out sine from these two terms, and then this term right here is just copied right there. And then I broke it up as the limit of each piece in my sum. And then I was looking at the squeeze theorem. So the squeeze theorem from chapter 1 said the limit as x goes to 0 of 1 minus cosine of x over x is 0. And the limit as x approaches 0 of sine x over x is 1. So I had to switch these around. So I took out a negative. That way my identity would work, or my my squeeze theorem would work. And I also split it up as sine x and then 1 times cosine x delta x over delta x, and then cosine x times sine delta x over delta x. Took the limit, so delta x went to 0. So that means this piece goes to 0 and this piece goes to 1 with the squeeze theorem. And I'm left with negative sine x times 0 and cosine x times 1, which ends with cosine x. So I just proved to you that the derivative of sine x, so when f of x equals sine x, I just showed you that, or proved to you that its derivative is cosine x. You can also do a similar proof for showing that the derivative of cosine is negative sine. From here, we looked at these practice problems, and just a hint right there, you're going to want to split that up first. And here you'll need to distribute first before you take the derivative. Okay. Let me know if you have any questions. I hope this video helps you out a little bit. I'll post all the notes without the video recording also on Canvas here in just a bit.